Hey everyone! If you're looking to get lip syncing working for your avatar or an image using just 8 gigs of VRAM and 32 gigs of system RAM, this video is for you. Now, full disclosure, you won't be able to generate long lip syncing clips with 8 gigs of VRAM in a single pass. But you can easily stitch these short clips together to create a longer sequence, just like I did here. I've personally optimized this workflow specifically for 8 gig cards. In this video, I'll walk you through the process step by step so you can get these same results. The model I'm running is SkyReels version 3. I tried using the GGUFs, but they kept throwing errors, so I'm sticking with the 19GB FP8 version. Here, I've included download links for all the models used in this workflow. Right under those, you'll find the model storage locations. Each model needs to be dropped into its corresponding folder inside your main models directory. First up is the WAN video block swap node. I've cranked the swap blocks to 40 since we're rocking 32 gigs of system RAM. This tells ComfyUI to aggressively offload parts of the model to your system RAM so your 8GB of VRAM doesn't get choked during the heavy lifting. I've set these to false to maintain speed. Since we've already handled the big chunks via block swapping, we want these embeddings staying close to the GPU for fast access. Here's the model loader. Quantization is set to FP8 E4M3FN. This is non-negotiable for 8GB cards. It slashes the VRAM footprint significantly, while keeping the visual quality sharp as a razor. Only enable Sage Attention if you've actually installed it properly. Otherwise, keep it disabled or it will definitely break your generation. Here's where you set your resolution. I highly recommend staying at 480p if you only have 8 gigs of VRAM. You can always upscale the video later using the newly released RTX Super Resolution. This is where you can select your text encoder. And this is where you'll upload your audio file. These audio duration and trim nodes calculate the exact length of the clip to ensure our video doesn't end abruptly or loop awkwardly. The Pater audio cut is a crucial node that aligns the audio perfectly with your video frames. For the audio split, I'm using the Melband Reformer FP16 model. The number of frames must match our audio cut perfectly, so the motion stays in sync with the sound. Here's where you can select your frame rate. This node takes our initial image and converts it into latent space, which is basically the language the AI actually speaks. I've added just a tiny bit of noise here. It gives the AI a little creative wiggle room, so the movements don't look stiff or frozen. Next, I've set the tiled VAE to true. It processes the image in small tiles rather than one big chunk. Here's our next node. The frame window size determines how many frames the AI looks at once. 81 seems to be the sweet spot. It's enough to keep the movement consistent without overwhelming the VRAM. Color match is set to Reinhardt Torch. This ensures the colors of the generated video match our original photo exactly. The step count is set to 4. The Flow Match Distill Scheduler allows us to get incredible quality in just a few passes. Since we're using a distilled model, I'm keeping the CFG at 1. This is where you'll need to enter your total number of frames. Usually this value should match the end frame you set earlier in the Painter Audio Cut node. For example, if you're aiming for a 7-second clip at 20 FPS, you'd set this to 141. I really don't recommend pushing past 7 seconds if you're working with only 8 gigs of VRAM. I upscaled every clip in this video using the newly released RTX Super Resolution node. Just make sure you keep the frame rate identical across both nodes to keep everything in sync. If you want to upscale your video to a specific fixed resolution, you can select the Target Dimensions option here. On the other hand, if you'd rather just upscale based on a ratio, go ahead and select Scale by Multiplier. Right below that, you'll find the Scale slider where you can set your desired intensity. For the lip sync clips in this video, I went all the way up to the maximum value of 4. Now check out the live generations.